So we are now on our last topic for anatomy. Yay! And it's the integumentary system. So the integumentary system would include your excuse me, your skin, nails, hooves, and the mammary glands and the other accessory glands, which includes also your sebaceous glands. Now, this is a normal canine skin. So basically, it has the epidermis, which is the outer layer. Then we have the dermis and the subcutaneous or hypodermis, where there's significant amount of fat in there. So the skin is basically Latin for this is cutis, and this provides a physical barrier for the body against the environment and microorganisms. This happens to be the largest organ of the body in terms of surface area. This also prevents loss of fluid. Color depends on the presence of pigmentation, and the skin's pigment protects the animal against ultraviolet radiation. So for example, our polar bears may look white because of their hair or their fur, but their skin is actually black. It is because the reason why they have that black skin, it's better in absorbing ultraviolet light, which keeps them warm. The color of the skin, naked skin, and non-pigmented air is also affected by various ways. By the blood in the blood vessels that perfuse into the deeper layers. This is according to Trice and Wensing. And if the animal's skin is bluish or cyanotic, this indicates that there's lack of oxygen. So this is one of the things when we do cesarean section and we try to revive the puppies, we check the extremities, particularly the palmar and plantar areas. Because if it's still blue, that means circulation is not, there's still problem with circulation. The animal still needs a lot of oxygen. And when you say yellow tint, it means it's icteric. It might be a sign of jaundice or icterus. And the skin is also the site where we synthesize vitamin D3. The structures of the skin. Now we start with the epidermis, which is a superficial layer of the skin that consists of continually renewed stratified squamous or squamous epithelium. And it's divided into 5 layers in which the cells divide in the deepest layer and it pushes up to form the specialized layers. As the cells grow out, they die and keratinize and they're finally shed from the outermost layer. So the stratum basale and stratum spinosum, these are the ones just below, right below it, just in between the dermis and epidermis. So when you say stratum basale, this is the basal layer, and it's the deepest layer that consists of a single layer of cuboidal to columnar cells capable of cell division. And these cells multiply pushing out to form the more superficial layers. This is according to Spaschini and Spurgeon. Stratum spinosum, on the other hand, is a spiny layer. And this is the layer above the stratum basale and is composed of polyhedral cells. And they have a prickly or spiny appearance, thus its name is stratum spinosum. These two are considered as stratum germinativum. So they're collectively known as stratum germinativum. Now, the next two are the stratum granulosum. So this is above the previous layer. So this is the third layer composed of squamous cells in various stages of degeneration, and it contains keratohyalin granules that are involved in the formation of keratin. Stratum lucidum, on the other hand, lucidum comes from the Latin term for clear. So technically, this is the clear layer. An inconsistently present fourth layer that is flat, dead squamous cells that may contain translucent droplets called elidin, which is from keratohyalin, and this will become keratin. And lastly, we have stratum corneum, which is the outermost layer So this is technically a horny layer, and it's composed of flat, dead cornified cells. It's completely filled with keratin, a waterproofing protein. So this is pretty much what it looks like. So we have the stratum basale, stratum spinosum, and then you have granulosum, lucidum, and corneum. Next, we have the corneum or the dermis. So the layer of the skin that is directly below and separated from the epidermis by a basement membrane. This is from ischemia and Spurgeon. And it's composed of collagenous and elastic connective tissues that contain blood vessels, nerve fibers, glands, and hair follicles. So the dermis has two layers, which is the papillary region or layer and the reticular region or layer. The papillary region is a layer immediately right beneath the epidermis, and it has a dermal papillae which is projected up into the epidermis, greatly increasing the surface area between the two layers, thus holding them together. The reticular region or layer is the deepest one, and it's responsible for variations in skin thickness, and named for the arrangement of the collagenous fibers in a network called reticulum. Subcutaneous layer, also known as superficial fascia, or you call it the hypodermis or subcutis. This is the layer of areolar connective tissue with interspersed fat that connect the skin, underlying the structures such as bones and muscles. And this is our preferred site when we give vaccinations. So when we give vaccinations, let's say it's subcutaneously, so since there's a loose in their neck, particularly in their nape area where the head and the shoulders will, the neck and the shoulders will meet, there's actually very loose skin there for both dogs and cats. So it's easy to pick it up using your hands. Just pull it up and then make sure that your needle is around 45 degrees in angle, and then you're able to do, you can give their injections via subcutaneous. So this is pretty how much it looks like. So you have the epidermis. This is technically the epidermis. So this is until, okay. Then we have the dermis, and then you have the subcutaneous tissues. Now we go to the hair. So hair is a long, slender, filamentous appendage of the skin which is composed of keratin, and it consists of a shaft and a root. So the hair follicle is a depression that contains the root, and they have a smooth muscle called the arrector pili that pull the hair into a vertical position if an animal is under stress, cold, or frightened. And the function of the hair is it keeps them warm or insulated. And this is, by the way, how you do your subcutaneous. So hair follicles of domestic animals, so horses and cattle, single hair follicles. For dogs, they have compound hair follicles with a single primary hair and a group of smaller secondary hairs. For pigs, they have single follicles grouped in clusters. And for cats, they have single follicle with a primary guard hair, the hair follicles that are surrounded by clusters of compound follicles. So this is how it looks like. So this is, you have sweat glands. This is the hair follicle. So types of hair, we have the guard hair, which lie close against skin and sweep uniformly in broad tracts that give the coat a smooth appearance. So it promotes water runoff and insulator. So our beloved Labradors have these. Wool hair, they have a soft undercoat and they are thin, wavy, and in most species shorter and more numerous than the guard hairs by which they are concealed. This is according to Trice and Wensing. Wool that is found in sheep exhibit an outer coat of very coarse, hollow cord guard hairs called the kemp. The kemp is to conceal and protect by facilitating runoff of the water. Tactile hair. Substantially thicker and generally protrude beyond the neighboring guard hairs. These are found on the face, and examples of this are the whiskers in cat. Characterized by the presence of a various sinus filled with blood and located between the inner and outer layers of the dermal sheath. This is from according to Trice and Wensing. And again, according to Dries and Wensing, the nerve endings responsive to mechanical stimulation are contained within the dermal sheath. And according again to Dries and Wensing, stimulus provided by disturbances of the hair is amplified by wave motion in the blood. So that's the reason why you should not cut off the whiskers of a cat. It's actually an extrasensory organ to them. Now, types of hair bristles. So these are the hair coat on the pig, cilia vibrissae, which is the nostril hair, and beard of the goat. You have a pair of beautiful, handsome horse. And this is the commodore, the Rastafarian dog. That is how much it looks like. So phases of the hair cycle, we have anagen phase, which is establishment of hair follicles and fully functional hair follicle. Catagen phase is the atrophy of the hair follicle. And telogen phase is the displacement of the hair distally, and new hair matrix is going to be formed. So this is how it looks like. Foot pads or tori. So provides cushion on animals when they walk. So they're covered by a naked, densely cornified epidermis. And the dermis is composed of thick subcutaneous and a mixture of collagenous and elastic fibers interspersed with adipose tissues. Best developed in plantigrade animals such as in bears, in which the digits, metatarsals, and metacarpals and tarsals and carpals are covered. Our dogs and cats are considered as digitrades. So this means that only the digits and metacarpals and metatarsals are covered in foot pads, but with the exemption of the accessory carpal bone. And then for ungulates, like it's found on the bulb on the ruminants and pigs. For horses, it's their frogs. If you notice, we're already leaning towards comparative anatomy, but you'll get to know more on this when you go to comparative anatomy soon. So these are foot pads. Sweat glands. Sorry if it says swear glands. It's sweat glands. So this is simple coiled tubular glands of the skin that open independently of hair follicles. There are two types, the merocrine, which are found in humans, pads of your carnivores, frog of the horse, nasolabial region of the ruminants and swine, and carpals of swine. And we also have the apocrine sweat glands, which are found in most domestic species. The function of the sweat gland is to maintain body temperature throughout the skin, and in most domestic species, it's the horse that sweats a lot. Sebaceous glands. So these produce fatty secretions called sebum that lubricates and waterproofs the skin and coat. This is from Dries and Wensing. Its function is to promote the spread of sweat, inhibit bacterial and fungal growth, and serve as territorial marker for some animal species. Lanolin is a sebum collected and processed from the sheep's fleas. And some sebaceous glands from musk deer and bear cats produce musk, which are scent binders for perfume. Mammary glands. Now, mammary glands is a modified sweat gland that produces milk. This is present in mammals for both male and female, and it consists of the mama and the teats. The development of the mammary glands in females is influenced by the hormone estrogen. However, milk production is being influenced by the hormone prolactin, and the milk letdown is influenced by oxytocin. So parts of the mammary glands for the mama, the glandular structure associated with the teat. So they have lobes. The lobes are internal compartment of the mama, which is separated by fat or adipose tissues. And each lobe are divided into lobules. And lobules also consist of alveoli, which are the grape-like clusters of milk-secreting cells of the mammary gland. They also have milk or lactiferous ducts, large ducts that convey milk from the alveoli to the milk sinus. And we also have the milk sinus, which is storage cavity for milk within the teat and the glandular body. The teat is the projecting part of the mammary gland, which contains part of the milk sinus, and it's lined with double layer of columnar epithelium. They have the teat canal, which is a duct that leads from the milk sinus to the opening, and it's lined up with stratified squamous epithelium thrown into the longitudinal fold, and these cells produce sebaceous plug in the teeth cells, in the teeth canal. So you have it here. So you have the mama. Sphincter muscles, these are muscular fibers around teeth opening that prevent milk from flowing except during nursing. And you have the Furstenberg's rosette, which are folds of teeth canal that binds into the teeth sinus. And you have it here. It's the Furstenberg rosette, which is present only in your cattle. And this is the final slide. So, congratulations. You have made it to the last topic. I hope you learned a lot during this time. I'm very sorry, but I really tried to make this concise enough. I've read 3 to 4 books for this one. All of them, if you're going to total them, it's around 2,000 to 3,000 pages all in all. But I managed to squeeze them to probably less than 200 pages, a total number of pages for these notes, because some of the things that you will read on your textbooks is just too much for your level. And if you're going to read everything, some of the informations might not be really important. So that's the reason why I have to make the notes because of that. So at least we have uniform notes. And this can be used, I know it's quite overwhelming, it's information overload also, because of the mere fact that this is anatomy and it's the most fundamental of the fundamental subjects that you have as technically freshman at sophomore year. At your age, you should be what you call this, you're still considered as having the fundamental subjects. Once you you're done with your 4th year subjects, you're considered as a clinician already. And always remember these things that we have discussed during the course of the subject, because again, these guys will again come back in the other subjects. At least these things have already been discussed to you, and whoever's going to be your instructor, at least that is being taken care of. It's just maybe he or she will just review you on basically an anatomy, probably quiz you just to check if you really indeed was paying attention to my discussion. And it's pretty much useful later on in your physiology. Some of these things will be useful in your pharma and your surgery. Particularly, these are things that it really needs that has to be taken first before you proceed to the next level. So I'll see you on comparative anatomy, hopefully. So this time around, we'll be comparing the anatomy of the different species of animals. And it's going to be a challenge. So till then, I'll see you later.